Hello guys and welcome again. It is your teacher Mr. J.F. Chavangwane here. We are continuing with our topic Euclidean geometry. Like we said, we will be focusing on it basically. If we have time, we'll be able to do more questions, but then for the first section we need to be sure about the theorems, and then after we are done with the theorems, then we can be able to see how we maneuver around and see if we cannot solve the problem, because this is an important question with your maths paper too. So you have to master and internalize the theorem. It's very important that you know all your theorems and you know their proofs, because the examiners in your paper, they can ask you any proof, and then you must be sure of your story. Like we have defined already in the previous videos, the first video we did on Euclidean geometry was basically to highlight and define the terms that are used in Euclidean geometry, the definitions of terms like tangent, chord, all those terminologies. And we also proved the center and the circumference theorem, which is the one that states the angle at the center of a circle is twice the angle at the circumference. So now we are moving on with another theorem, which is called the Chord Theorem, or also alternate segment theorem. Now we have to prove the theorem, but before we prove the theorem, now let us look at the theorem. What is it saying? Now they are saying now the circle, given a circle with the center O, so now we know that the circle has that center O, and then we are asked to prove that DAC is equal to ABC. So DAC, which angle? DA, let's look at it. DAC is DAC, so is this angle, right? We want to prove that this angle is equal to ABC, so this is what we want to prove. So now we must make sure we understand the Chord theorem, because we have a situation whereby learners are unable to understand really what is the Chord theorem. Now the Chord theorem is saying, let's write it down. So Chord theorem states that the angle between the tangent and the tangent and chord is equal to the angle subtended by the chord in the alternate or opposite segment. So now we see that it's important that you understand the language, the terms that are used there. Now they are saying the angle between the tangent and a chord. So now the first thing that you need to know what is a tangent, what is a chord. So when we are talking about a tangent, we are talking about a line that touches the circle at only one point. So this line, the tangent 8D, touches the circle at A. That is the only point where the tangent is touching that circle. So if a line is touching a circle at once or at one point, it is called a tangent. So when we talk of a chord, you know that the chord is a line which is in a curve and has both endings in the curve. So now this line is our chord AC. You have chord AB, you have chord BC. So now the theorem is saying that the angle between the tangent, where is the tangent? This is our tangent. Now we need the angle between the tangent and what? And a chord. Which chord? It's either AC or chord BC. These are only chord AB and chord BC creates an angle with our tangent. So now we need to understand that now you have a chord and a tangent. They create angle DAC. We need to prove that the angle between the tangent and the chord is equal to the angle that is subtended by the chord in the opposite segment. So let's see. Now, if you have an angle which is in this, which is here in this, which is here this side, now the angle is equal to the angle subtended by the chord in the opposite segment. It is opposite to an angle that is created between the tangents. So this angle is in this side, so the angle that is equal to that is in the opposite segment. So don't say this angle is equal to that, no, right? So now we look, this angle is equal to that one, because this angle is opposite that and is subtended by the chord and the tangent, right? So if we continue and we look at this one, let's say this one, this angle, you see this line is also a chord and that is a tangent, so they create an angle. But the angle, this angle is equal to the angle in the alternate or opposite segment. Where is the opposite of this side? It is that angle. So make sure you understand. Don't say this angle and that they are equal. No, this angle and the angle in the alternate or opposite segment. So that's all about the Chord theorem basically. So now to prove this theorem, you need to revise and rewind back to your theorems that you already studied, right? We will need the theorem that says we need the theorem of angle in a semicircle. These are the theorems that we'll utilize. That is theorem number 1, or this one, angle at the center is 2 times angle at the circumference, right? That is the first theorem that we will need to utilize. The next one, we need to know already that if you have a line that is drawn from the center, that line will be perpendicular to your tangent. So that is another theorem that you need to know in your mind. Tan is perpendicular to radius, or line drawn from the center, radius, or line drawn from the center, right? So if there's a line that is through the center and is meeting the tangent, the angle that will be created there is 90 degrees. Remember that. And number three, we need the theorem of angles in same segment. So these are theorems. The theorems, you need to know all of them, right? Make sure you internalize them. So now the question that we were asked here, we were asked to prove that DAC is equal to ABC. There are many ways you can prove these theorems. So now you must not only be confined to the one that I'm doing. You can use any other method that is favorable to you. So now to prove the theorems, we need to do the construction, right? To do the construction. So now we can do our construction. The construction, you draw a line. Our construction, let's use a bigger color. So we construct a line through the center. We construct a line through the center, right? And then extend it to point E and have point E there. So now which angle are you relating? You want this angle, and it's related to which angle? The angle that is in the alternate or opposite segment. So which angle is in the opposite segment? It is angle B. So you construct from B to E, right? You construct another construction from B to E. Even if you don't know what is next, you know the drawing, you already have a mark to do construction. Make sure you show your constructions. You do not have to memorize the proofs without construction, right? Now, after construction, now we have A1 and A2. And then here we have B1 and B2. So, We don't have space. Let us erase here so that we open some space. I'm sure you have that in you. Okay, let's erase. So now the first thing we do, okay, so I said the first statement you do, you see, we said we'll need other theorems. So now we notice that angle B1 plus B2. So what is the angle that is created here, right? So if you look here, this angle here, it is a straight line, right? So what is the angle here? The angle is 180, and then we know that the angle that is at the center is twice the angle that is the circumference. So what is the angle that is created there? The angle becomes 90, because the angle at the center is twice the angle at the circumference. So if this is 180, that means that is 90 degree, right? You are saying that B1 plus B2 is equal to 90, right? 90 what? Degrees. So you must put these caps to show that you are talking about angles. It is equal to 90. So you can say the angle at the center is twice angle at the circumference, or you say angle in a semicircle. So this is a half circle from here. If you divide it through your center, then you have half circle. You have this circle that is half, and that other circle. So you can say angle in semicircle. Angle in a semicircle is 90. Angle in a semicircle, they create an angle of 90. So what else do we see? We see that angle B, angle what? Angle B1 is equal to angle A1. What is that reason? Angle in the same segment, that means angle that are in the same segment, they are equal, right? Angle in same segment. So which segment? So you see, this is the segment. So this angle that this segment creates which angle? It creates that angle B1, and also the same segment creates angle A1. So angle that are in the same segment, this one is holding this angle, you see, A1, and in the same time is also holding B1. So those angles are equal because they are in the same segment. So next we continue. Now you have A1. What is A1 plus A2, right? I'm sure you can tell me there. What is that? You see, now you have a line that is from the center and the tangent. So what is the angle between a tangent and a radius, or a line through the center? That angle is equal to 90. So you get A1 plus A2 equals to 90 degree. Why? Because radius is perpendicular to your tangent. So you have radius perpendicular to tangent, right? So this line, the radius here, is perpendicular to that tangent, right? So next, what do we see? Let's erase and open some space, some more space here. Okay, let's open some more space so that okay. So now we have two equations that are equal to the same value. So you see this one, sorry, do you see? Let's use a different color. So now we have this one and this one. So you see P1 plus P2 is equal to 90, and A1 plus A2 is equal to 90. So that means if you if me and you, we are equal to the same thing, that means me and you were also equal. So P1 plus P2 is equal to 90, A1 plus A2 is equal to 90. So this implies that P1 plus P2 is equal to A1 plus A2. Why are we saying that? Because this is equal to 90, right? 90 is equal to 90 degrees. So that's why we have this here, right? They are both equal to 90. So in Euclidean geometry, you must make sure that you write every reasoning. You don't just wake up and think, right? So which angle are we looking for? Now we are looking for angle DAC. So angle DAC is the same as angle A2, right? So from this equation, I can make A2 the subject of the formula. Here we can transpose this one to that side, and then we remain it A2 equals to B1 plus B2 minus, now if you move this A1 to the other side, it becomes negative A1, right? So let's rewrite our equation in a format that is friendly. So it doesn't matter whether you write it like this or you write it like this. Is the same thing, right? B1 plus B2 minus A1. So now now you go back to ask yourself, which angles do I need to relate? The angles that we are relating here is angle A2 and B2. Now, which angles are not there? B1 and A1, they are not part of our problem. But we said, remember here, you remember what we said here? We said A1 is equal to B1. So you can substitute either A1 or B1 with one of the two. So B1, I choose to replace A1 with B1. B1 plus B2 is minus A1, and then in the place of A1 I put B1, right? So what is this one? B1 and B1. This is positive and a negative, so this one subtracts that one and you remain with B2. So A2 is equal to B2. So that means A2 is equal to B2. So we have already proven that, so it's quite easily done. So you've proven that. But then you did not answer the question. You see, the question is having DAC and ABC. So you see, DAC is equal to, what is, let's write the equation now. Let's write what we have now. Now you have A2 equals to B2. So what you were given here is DAC, and DAC is equal to A2. So you can say DAC, right, is equal to B2. What is B2? ABC. B2 is A, B, C. So it is equal to B2. So this is A, B, C. Okay, so we have proven the Chord theorem. I hope you understand. In case you do not understand, the comment sections here is here for you to ask questions. So thank you very much for watching the video. We are coming up with more videos. I'm sure you are following, you are studying at home, you are safe, you do not move around to be safe from the coronavirus, you are washing your hands regularly. You make sure you self-isolate yourself.